Hello, welcome back to a Math 055 video. We're going to be talking about section 6.6, which is division of polynomials. Okay, so before we kind of talk about the division of polynomials, let's kind of talk about division of numbers, okay? So let's do this. The first thing I want to do is kind of talk about some fractions here, okay? Remember that if you're taking... if we write the word fractions down, fractions are division. Fractions means division, okay? And a lot of times, if we can't divide things, we just leave them as fractions, okay? So that's kind of something that we need to, take care of. So we want to recall something. Let's say I want to add, say, like, 1/7 plus 2/7 plus 4/7. Okay, add all those numbers together. Now, what I would do if I were adding these fractions together is understand that I have a common denominator. So what I would do when we have common denominators, I just want to add my numerators, so 1 plus 2 plus 4, all divided by 7. Okay, and then we would add our numerators, and we would get 7/7, which would end up giving us 1, okay? But I want to talk about this step here, okay? This step going from 3 separate fractions to 1 fraction is when you have a common denominator, all right? Now, what we're going to do is, because we have a common denominator, when we're dividing polynomials, we're going to start here, and we're going to go backwards. So what that means is, if you kind of look at what this says, recall that if you have a fraction with a common denominator, we can separate that out into individual fractions. Okay? So we're going to use the property above to split up rational expressions so that you're dividing monomials by monomials. All right? Simplify each rational expression, and we can check our answer by multiplying the quotient by the divisor, and we should arrive back at where we started, okay? So what I've got here is I've got this, all right? And I want to divide, and what I have here, this top part is a polynomial, all right? I have more than one term, okay? Terms are separated by the plus and minus symbols. And what I'm going to do is divide that by this common monomial. So what I have, like I said, I have a polynomial divided by a monomial, and I want to divide this and simplify it. So the way I would do this, if I divide this by a monomial, which is a one term, okay, what I'm going to do is I'm going to separate all this stuff out. And I'm going to write this as 16y to the 4th z squared divided by -4y to the 4th z minus 8y to the 6th z to the 4th over -4y to the 4th z, okay, plus 12y to the 8th z cubed over -4y to the 4th z. Now what I'm going to do is I'm going to simplify this, and I want to look at my numbers first, okay, and then I want to divide everything else out, okay? So I'm going to look at my numbers. I will then look at I have y values that I need to divide out, and then I have z values that I need to divide out, okay? So let's first start with 16 divided by -4, okay? If I do that division, I'm just going to get -4 out of this, okay? If I look at y to the 4th divided by y to the 4th, it's going to divide out to 1, all right? So I'm just going to leave that as 1, so times 1. And then if I've got z squared divided by z, now that my exponent here is 1. Now if I'm dividing these, I want to subtract my exponent. So I would write this as z to the 2 minus 1 power. Okay? All right. On the next one, let's take a look at our numbers. I've got -8 divided by -4. That's going to give me +2. All right, so I'm going to circle this up. Okay, so it's going to give me +2. So +2. Let's look at my y values. Y to the 6th divided by y to the 4th, it's going to give me y to the 6 minus 4 power. And then if I've got z, z to the fourth over z. I'm going to write that as z to the 4 minus 1 power. Okay. On this next part, let's take a look at these numbers. I've got 12 divided by negative 4. All right. I've got y to the 8th divided by y to the 4th, and then I've got z cubed over z. So what I end up getting here is I'm going to end up getting minus 12 divided by negative 4 is 3. Okay. Y to the 8th divided by y to the 4th gives me y to the 8 minus 4 power. And then I've got z to the 3 minus 1 power. All right, so if we simplify this, all right, gives us a nice easy number. So I'm going to get negative 4z to the first power plus 2 times y squared z cubed. And I'm just doing these operations here. And then minus 3y to the 4th z squared. Okay? And that's it. All right, and that's my answer. Now what we could do is we could check this if we were to take this resulting polynomial and multiply it by our divisor, we should get our numerator that we had. Okay, so you can always check. All right, we don't have enough time in that video to do that. So let's take a look at this one. Now what I've got, this one should be a little bit easier, and I'm going to skip my steps. I'm not going to show every step on this one, but I'm going to rewrite this so it makes a little bit of sense, because I have this polynomial divided by this number, okay? Now what I have is this. I'm going to write this as x cubed y squared minus x cubed y cubed minus x to the 4th y squared divided by x squared y squared. Okay, I'm going to separate this out, and I'm going to do x cubed times y squared over x squared y squared minus x cubed y cubed over x squared y squared minus x to the 4th y squared over x squared y squared. Okay, now I want to just subtract my exponents here. So a lot of these we can do pretty quick. So 3 minus 2 for x is just going to give me x to the 1st. Okay, y squared divided by y squared is just going to divide out to 1. All right. Minus, I've got x cubed over x squared, so it's just going to give me x to the 1st. And then y cubed minus y squared is going to be y to the 1st. All right, minus x to the 4th over x squared is just going to give me x squared. Okay, and then y squared over y squared is going to divide out to 1. All right, so if I wanted to write my answer, I'd write this as x minus xy minus x squared. And that's that. And we're just doing division. Okay, so that's the idea when we're taking a polynomial divided by a monomial. Now, things kind of change a little bit when we do dividing polynomials by other polynomials and doing long division of that. All right, so let's think of just dividing numbers. All right, so let's do this. Let's go, let's do long division. So let's just kind of remember long division. All right, and let's say I have this. Let's say I have, I don't know, let's just do 10 divided by 3. Okay. You know, when I write that fraction like that, 10 divided by 3, I could really write this as 10 divided by 3, okay? Or I could write this as, all right, so I could write this also as 3 or 10 divided by 3 like that, all right? And we're going to focus on this form, because that's how we're going to do long division using polynomials, okay? So if I do this, you know, what I think of is this. You know, if I do 10 divided by 3, I ask myself the question, okay, how many times does 3 go into 10? All right, and that's 3 times, all right? And so 3 times 3 is going to give me 9, and I'm going to subtract those values, and I get a remainder of 1, okay? So because I have a remainder of 1, if I wanted to write out this division and write out my quotient, okay, so this is my quotient, this number here. This is the result of doing division. This here is my remainder. So then how I would write my quotient, if I have a remainder, is I would write 3 as my quotient, and this number comes from here, all right? And then I would take my remainder and divide it by my divisor. So this number here is my divisor. Okay, so I would write this as 3 over 1/3. Okay, so this number here was my quotient. All right, this number here was my remainder. And this here was my divisor. Okay, so that's how we'd write our answers. Now, if I take 10 divided by 3, we know that we're going to get, if I do this division, all these answers here would give me 3.3 repeating. All right, which is the same thing as writing 3 1/3. Okay, and that's the idea. So that's what we're going to do down here when we do this on polynomials. Okay, so we're going to divide these. All right, so what I'm going to do is I want to make sure that, there's a couple things we've got to take care of, all right? We want to make sure that we arrange our polynomials in descending order. If there are missing terms, okay, we write them with 0 coefficients and leave space for them, okay? I'll show you how to do the long division process. We'll write our answer here as the quotient plus the remainder over the divisor, and we can check our answer by remultiplying, okay? It's any way we can check. All right, so let's do this. All right, if I divide, say, x squared minus 9x plus 21 by x minus 4, okay, my divisor is x minus 4, and my dividend is x squared minus 9x plus 21. So that's how we go from this form here into long division form. Now, here's what I do, okay? What I ask myself is this. X times what number is going to give me x squared? And that's going to give me x. Okay? So now what I do is I take x and I multiply it. So I take my quotient, my first part of the quotient, and I multiply it by this entire quantity here. So if I do, say, x times x, it's going to give me x squared. If I do x times -4, it's going to give me minus 4x. Now what I do is this, is I subtract the quantity. A lot of times we're going to make the mistake of not subtracting the quantity, all right? And so I'm going to do x squared minus x squared is going to give me 0, and that's the idea. Those cancel out. Then I have negative 9x minus negative 4x. So negative 9x plus 4x is going to give me negative 5x. Okay? And then I drop down the 21. All right? So plus 21. Now I repeat the process. All right, so now what I have is I do the same thing. And I'm going to say, okay, x times what gives me negative 5x? And that's just going to be minus 5. All right, so if I do minus 5 here, okay, now I'm going to take negative 5 and multiply it by x minus 4. So negative 5 times x gives me minus 5x. Negative 5 times negative 4 is going to give me positive 20. All right, so now I'm going to subtract the quantity, all right, and what that's going to end up giving me, I've got negative 5x minus negative 5x, so that's going to cancel out, okay, and then I've got 21 minus 20, which is going to give me a remainder of 1. So this is my remainder, all right. So what I want to do now is write my quotient, and my quotient, my answer, after I do this division, is going to be x minus 5 plus my remainder divided by my divisor. And that's my entire answer. Okay? All right, let's take a look at this last one. All right, now what I notice here is that I've got 6 plus x cubed minus x. Let's rewrite this in standard form. So I'm going to write this as x cubed plus 0x squared minus an x and then plus 6. And then I'm going to divide this by x plus 2. So the reason why I rewrote this, I have to put this into ascending order. So I have to put my largest exponent first. Now, what I also notice about this polynomial here is it does not contain an x squared. So I still have to put that in there as a placeholder, okay? And then I write everything else normally like that. So let's put this into long division form. Let's do x plus 2 divided by, or it goes the other way around, x cubed plus 0x squared minus x plus 6, and we're going to divide that by x plus 2, okay? So now I do the same thing that we had done, and I'm going to ask the question, x times what gives me x cubed, and that's going to give me x squared. Okay, so I'm going to put that above my x squared. Okay, so now I take x squared and I multiply it by the quantity x plus 2. So I take x squared times x gives me x cubed. Okay, and then I take x squared times 2, which gives me 2x squared. So plus 2x squared. Now I subtract the quantity from that. All right, so I've got x cubed minus an x cubed. That's going to cancel out, add to 0. Then I've got 0x squared minus 2x squared. So we're going to get negative 2x squared out of this, drop down my negative x. We're going to repeat the process. So now I say, okay, I've got x times what gives me negative 2x squared. It's going to give me negative 2x. So negative 2x. All right, so then I'm going to multiply negative 2x times x, and that's going to give me negative 2x squared. All right, and then negative 2x times 2 gives me negative 4x. Okay, subtract the quantity. All right, and then we're going to get negative 2x squared plus 2x squared. Okay, subtracting that quantity, so subtracting a negative. That's going to cancel out to 0. If I've got negative x plus 4x, that's going to give me 3x. Okay. All right, and then we're going to drop down the 6. Oh, this is looking good. All right, so now if I take x times what gives me 3x, it's just going to give me a positive 3. All right, so now what I've got is 3 times x plus 2, which is going to give me 3x plus 6. So 3x plus 6, subtract the quantity, everything, 3x minus 3x is going to add to 0, 6 minus 6 adds to 0, and I have a remainder of 0. Okay, so because I have a remainder of 0, okay, this divides evenly. All right, which is kind of something that we are always looking for when we are doing division. Sometimes these don't divide evenly like we had here, and we get a remainder, all right, and that's not good. But if we do get this, we get a remainder of 0, this divides evenly. Now let's kind of talk about what this is, all right? So let's write out my answer. Our quotient, once we do this division, we get x squared minus 2x plus 3. Now let's talk about this for a second. Why are we doing this? Is a big question, all right? If I were to redo this and check with multiplication, okay, if I take x plus 2 and multiply it by x squared minus 2x plus 3, I will get what I started with, okay? I'll get x cubed minus x plus 6, all right, and that's the idea. Really what I'm doing here, this is a method of factoring, all right? So when we were doing factoring, okay, the cool thing that we were doing was we were saying, like, we were just doing trinomials. We were just doing things with x squared primarily. But what long division allows us to do is allows us to take really big polynomials. Like when you have, like, say, something of, exponent of 3, 4, 5, you can do long division to break this down. And it helps with you factoring things that are of larger degree, okay? That's why we do that, all right? So that's the idea. All right, so here's your homework. Hope you enjoyed this video, and we'll see you soon. Thanks a lot. Bye.